Hey guys, I'm back. Not gonna talk a lot on this one, I don't think. Anyway, here's the Ram B. I could be wrong though. Here's the Himawari-8 latest run. Same deal. Showing up around 1350, 1340 UTC. Well, you can see it's casting light. Even way out here, and there's the stair step pixelated activity. Click it through. See, quite a bit of reflection. And I still submit it's being reflecting the sun simulator, being that it's a more narrow, highly focused beam than the sun. Why else would you have highly focused white beam coming back at us, back at the earth, whatever. So there you go there. There's more pixelation. You can see they have this whole thing pixelated out. So I'm surprised nothing surfaced on the internet yet about pictures of this thing down somewhere in the southern hemisphere. It should be showing up. I don't know. Crazy. I know they wouldn't be able to censor everything. So, for some reason, I'm not seeing anything. If you guys see anything, throw a link in there in the comment section. So let's see what else we got here. There's the current space weather. Latest run. 300 frames. Really not much missing time. A couple hours, I think, at one point in here. Wind speed's really low, as it is on ACE and Discover, which I'll show you in a moment. Just let this play through for a minute. Got these three synced, and these two are synced. They're measuring the heavy electron radiation coming from Nemesis back here, bathing the planet. That's the geosynchronous orbit where the weather satellites go around. The one I just showed you, the Himawari-8, that's up there. Along with the GOES 16 and GOES 17, where we get our weather from. And also these two, which I think are what are providing the data for these simulations. The blue, huge plasma energy being discharged away from the planet. Planet's fighting hard. Black field lines that normally just flow away from the Earth. You can see there. Sometimes they've been having to close in order to garner extra energy from the Earth to repel all this backside pressure. Now, all this pressure out here, this density, I think it can't be coming from solar wind, because solar wind speed's real low. I'll show you that on ACE. And like I showed you earlier, this has been going on for 3 days plus. 3.5 days, I think it is now. Where the pressure is almost equalized between the backside pressure from Nemesis and the front side pressure from the sun. See, we're getting a little bit more pressure here, but I think what's happening is, you saw the density here, the red showing up. What's going on is it's just being piled up right here. Now this is the ACE for the last 24 hours. See the solar wind speed, they got it dialed down real low, 280 to 310. So they got 5 kilometer per second increments, which is extremely low. The average solar wind speed between 400 and 700 kilometers per second. It's gone down as low as 280, it looks like. Plus it's all fluctuated. Same with the density. So something's perturbing it. It's not the interplanetary magnetic field connections. That's fairly steady, although there's a spike there. And anything above 180 indicates the Earth is connected to something behind our planet. A sun behind our planet. At 180, it's Earth. It's Sun to Earth. At 0, it's Earth to Sun. And if you pull up the Solar Ham tutorial in the description box, it explains it quite easily. It's like it's on a 6th grade level, but it explains everything in a good fashion. The phi angle. Let's see if this thing came back up. Okay. Well, this is the last 7 days. So there's Discover on what I just showed you, ACE last 24 hours. Here's on the Discover, which is up the same area, the L1 Lagrange point. Same deal. I mean, solar wind's really low. Don't appear to be as much perturbation and fluctuations on here, though. Although you can see the phi, and you can see the phi angle. Maybe that's showing a little bit more perturbations, but it's still all above 180. And these satellites are up at the L1 Lagrange point, but they're obviously not that close together because we got the big gap here on ACE. It's like almost those 700 hours, those 630 anyway. There's 20, that's at least 8.5 hour gap. So there's something big out there near the ACE satellite that's interrupting the solar wind and the data collection thereof. And I think maybe it's also causing these perturbations, whatever it is. Probably a planet with some type of a magnetosphere, similar to the Earth having a magnetosphere. And maybe that's what's scrambling all this data. Anyway, here's the last 7 days. So you can see, normally we did have that 8-9 hour gaps normal. Then it went down to like a 4 hour gap there, 4 or 6 hours, 3, 4, 6 hour gap. Then the gap went away. The 16th, there was no gap. 17th, no. Then it came back on the 18th, but we only had like a 2 hour gap and a 4 hour gap. Then we had another 2, 4, 6. So there's the 8 hour gap back on the 19th. Then we had 2, 4, 6. And there's the 8 hour gap back on the 20th. And I guess it's back again on the 22nd. But if you look at, this is on a Discover satellite for the last 7 days. And you can see the gap's totally different. Very seldom you get a gap on Discover. So even though it's up there at the same L1 Lagrange point, it's obviously not that close to ACE, or whatever's causing those gaps on ACE is very close to ACE. I'd say a combination of the two. So we have a little gap on the 15th, 16th, 17th, we had like 1, 3, maybe a 5-hour gap, then no gaps on the 18th, 19th, 20th, or the 21st. Crazy stuff, guys. And the solar wind density, normally, I looked it up today, the normal is between 4 and 6 atoms per cubic centimeter. You can see that pretty high. Well, not that high, but it went up over 8. There, 7, 9. So something's causing the solar wind to bunch up, even out as far as 8th, which is 930,000 miles in front of the Earth. And on here, I don't know, these looks like they have the increments different. Well, apparently that's 1. This has to be negative density. Or no, not negative, but from 0.1 to 1 it goes. So this is like real low. That's what I'm talking about. There's something out there maybe with a magnetosphere planet. It's causing these gaps on ACE, and it's messing with the solar wind density being recorded on ACE, because they're both 930,000 miles in front of the Earth and between the Earth and the Sun. MLSO, here's October. They're not giving us much at all. Another X out for the 20th. I'll just let this one play. Well, we'll step it through one more time. So here's the planet that's invaded below the weather satellites. Himawari at 22,200 and someone told me 41 miles, 2,241 miles above the Earth. So it's between 22,236 and 22,241 miles above the planet in that geosynchronous orbit. And this is on the natural color. Just select this band here if you go in and do it yourself. That gives you the best look. There she goes. So you can see the solar wind's really down, even inside the geosynchronous orbit. All this data is being recorded by these ghost satellites. So I don't know, I say we're still at some point of like calm before the storm, as I mentioned in, even put it in the title, I believe, one of the videos this week. We're into sort of some type of a holding pattern, equilibrium stasis condition, interplanetary electromagnetically speaking. That's my opinion. Density's piling up in front of the planet because of the equal pressures coming from the sun and from Nemesis. And it's also piling up out here in front of ACE. It's even piling up, solar wind density's piling up even out here, 930,000 miles in front of the Earth. This is the L1 Lagrange point I was talking about. And there's some good links in the description box. Definitely check out this L1 Lagrange point link and the Solar Ham space weather tutorial. So there she blows. So around a little bit before 11 p.m. Australia time, Melbourne time, it starts to sweep across the bottom of the planet. Alright guys, I guess that's about all I got here. God bless, peace, and I'm out.